Welcome to RPS Group of Schools online classes. Today we are going to start a new chapter from physics portion of your textbook, Motion and Time. This is session 1. We see a variety of objects in motion around us. For example, cars moving on the road, players moving in a football ground, stars moving from east to west in the night sky, a swing moving to and fro, and kids running in the playground. So what do we actually refer to as motion? Recall what you have learned in the previous class. In the previous class, we have studied that an object is said to be in motion if it changes its position with respect to a fixed point or a fixed object. So, if an object changes its position or moves from one location to another, we can say that the object is in motion. In the previous class, we have also studied that motion can be grouped into different categories as rectilinear motion, motion of an object along a straight line, curvilinear motion, motion of an object along a curved path, revolutionary motion, motion of an object in which whole body moves along a circular path, rotational motion, motion where a body spins on its axis, oscillatory motion, to and fro motion of an object around its fixed position, random motion, an unpredictable motion of an object where the direction changes continuously, and periodic motion, motion repeated in fixed intervals of time. If you observe carefully, you will find that the motion of the objects may be either fast or slow. Imagine two cars heading towards the same destination. How will you find which one is faster and which one is slower? An object which covers more distance in a smaller interval of time is said to be faster as compared to the other. Here, the car which reaches the destination first will be faster. So we can conclude that slow and fast are comparative or relative terms. What if the cars are moving in different directions and heading for different destinations? Will it still be easier for you to find out which one is faster? To find this, we need to calculate the speed of each car. Speed is the rate at which a person or an object covers a distance, or speed of an object can be defined as the distance traveled by the object in a unit time. To calculate speed, we need to measure the following details: the distance traveled by the object and the time taken to travel this distance. The formula for calculating speed of an object is as shown. Speed equals to distance traveled by an object divided by time taken to cover this distance. Symbolically, it can be represented as shown here, where V stands for speed, S for distance, and T for time. A fast-moving object has higher speed, which means it will cover comparatively larger distance in a short period of time, whereas a slow-moving object has lower speed. The SI unit of speed is meter per second. In case of longer distances and duration, it is inconvenient to express speed in meter per second. So, kilometer per hour is used in such cases. Let us study the relation between the two units for measuring speed, that is, meter per second and kilometer per hour. We know that 1 kilometer is equal to 1000 meter and 1 hour is equal to 3600 seconds. Therefore, 1 kilometer per hour equals to 1000 meter upon 3600 seconds. On solving further, you will find that 1 kilometer per hour is equal to 5 by 18 meter per second, or we can also say that 1 meter per second is equal to 18 by 5 kilometer per hour. In order to convert speed of an object from kilometer per hour to meter per second, just multiply the given speed by 5 by 18. This will give you the speed in meter per second. Now let us solve some numericals based on interconversion of kilometer per hour and meter per second. A bike is moving at a speed of 60 km per hour. Calculate its speed in meter per second. We know that 1 km per hour equals to 5 by 18 meter per second. So, 60 km per hour equals to 60 multiplied 5 by 18 meter per second. On solving this, you'll come to know that 60 km per hour is equal to 16.67 meter per second. So, the speed of the bike would be 16.67 meter per second. Now let us solve another question. Nakul is driving his car at a speed of 20 meter per second. Calculate the speed of his car in kilometer per hour. We know that 1 meter per second equals to 18 by 5 kilometer per hour. So, 20 meter per second will be equal to 20 multiplied 18 by 5 kilometer per hour. On solving this further, you'll come to know that 20 meter per second is equal to 72 kilometer per hour. So, the speed of Nakul's car is 72 kilometer per hour. That was all for today's class. Thank you.